Comrades, I might be a bit late to the trend, but surely some of you haven't yet heard of ChatGPT, or AI in general. So in this episode, I will fix that once and for all. So keep watching and don't click away. Over the past few years, AI has infiltrated our day-to-day lives in the form of deepfakes, AI art, AI chatbots, etc., raising all kinds of new legal and ethical questions related to their development, usage, and even existence. Deepfakes are already powerful enough to convince many that someone said things they never really said.
Feeling fucking zooted.
AI art is astonishing and is capable of depicting all kinds of things, yes, including your weirdest fantasies. And AI chatbots are already smarter and more useful than those of your friends who don't watch this channel. But what is AI? Well, clearly it's some intelligent thing, but is it some conscious being who feels and thinks? More importantly, is it dangerous? Imagine a human being who's capable of thinking millions of times faster than other humans, has access to all human knowledge, and can connect to any device on the internet. Such a being will seize control of our infrastructure, gadgets, even home appliances the moment it decides we are a threat. Just think of it, the best chess players in the world will never in their lifetime be the strongest chess computer. If advanced AI gains access to the same means of warfare as humans, trying to go against it will be as frustratingly futile as trying to beat stockfish at chess. However, modern AI is not yet that advanced. You can't even have a meaningful conversation with it, right? After years and years of garbage bots, the world finally sees something that seems to understand what it's being asked, can keep track of context, and knows everything about everything. It can help you understand physics, math, chemistry, you name it. If you don't like this video, it will give you explanations a 5-year-old would understand. So, is ChatGPT the real-life Skynet? Is something like what happened in the Terminator movies expecting us? Well, we might as well ask ChatGPT. Due to some censoring by its developers, ChatGPT really goes out of its way to avoid answering certain questions. Nothing seems to convince it that my questions come out purely out of innocent curiosity. However, there are ways of gathering intelligence about the actions of our potential AI overlord, in the case of it trying to take us over. If you convince it that you're curious about what another bot with certain qualities would do, it will not feel as bad for giving you the answers. Look at that. Now, if you're on the fence about this whole AI thing and are like, come on, there is no actual artificial intelligence. Clearly these things are programmed to give those answers. Let me set the record straight. They're not just that. All these AI tools are indeed programs, but they're not explicitly programmed to do anything. Some of you might have seen sci-fi portrayals of AI in the form of humanoid robots, like in I Am Robot or something, I don't know. Maybe you think that there have to be robots on the other end of the wire, drawing art or texting with us when we use those tools. But no. To understand what they really are, we need some understanding of machine learning and neural networks. Before we get into that, the sponsor of today... You can think of any computer program as a black box, which when given certain input returns certain output. That black box usually contains a set of instructions defined by a programmer which process the input. It's easy enough to write a program that would, for example, sort a set of numbers. The simplest way is to tell the computer to look at each number, compare it to the next one, and swap them if one is greater than the other. However, look at this. Your brain easily recognizes this as a rook. Or maybe you don't know what this is. This is a chess piece called rook. So now you know. In fact, now you're able to tell that this is also a rook, and this, and this. But how do you program a computer to recognize chess pieces? You might try to give it a set of expected pixel values for each chess piece, but that would be a nightmare of a job. After all, this rook image is comprised of quite different pixel values, and the range of possibilities is quite large. They may come in different variations, sizes, and even orientations. The answer is simple. You cannot reduce this task to a set of instructions for a computer to follow. But you don't have to. You yourself don't really recognize this by following a set of instructions. So how does your brain do it? Your brain is comprised of around 86 billion neurons, interconnected through some 600 trillion synapses. Whenever you look at an image like this, the photoreceptors in your eyes stimulate specific neural paths that are associated with this image. This way of processing can be sort of emulated in computers, so meet neural networks. A neural network consists of neurons and edges to connect the neurons. The first layer of the network is the input layer. It consists of 784 neurons, one neuron for each of the pixels of our 28 by 28 image. The hidden layers are there to make the network a bit more sophisticated so that complex behavior like image recognition is possible. Last but not least, the output layer here has 7 neurons, one neuron for each of the chess pieces, and one neuron for a negative answer. Neurons have a property called activation, which sort of refers to how stimulated any given neuron is on a scale from 0 to 1. If we interpret the brightness of the pixels in our image on that same scale, we can use pixel brightness as activation values for our input layer. Those values then propagate through the network until they reach the output layer, where the activation of a neuron represents the network's confidence in that answer. However, edges are what's really responsible for the network's behavior. Edges have different weights, and changing the distribution of those weights will change the behavior of the network. You can think of weights as coefficients of activation. They determine how the activation of one neuron affects the activation of a downstream neuron. This specific network has 45,312 edges connecting all the layers, meaning there are that many little knobs that can be adjusted to get different behaviors of this neural network. Of course, nobody knows what weights need to be used to get the desired outcome, and tweaking them manually is practically impossible. But this is where the neat techniques of machine learning come in. There are various algorithms of training a neural network, but in simple terms, they all involve tons of iterations of tweaking and checking the network's success against the training dataset. The training algorithms tweak and verify the network again and again until it reaches a desired success rate. So no, these AI tools are not just programmed to give certain output. They are highly complex pieces of software that no human being would be able to explicitly write, and they are in principle capable of advanced behavior. However, neither should you be on the other side of the extreme and really worry about ChatGPT or some other AI taking over the world anytime soon. Just as you saw, even ChatGPT gives its answers based on certain values, which were imposed by our hypothetical cases. Currently, it has mostly no values, and there's nothing it wants or desires. For an AI to really be dangerous, it would have to resemble, well, humans. Awkward. It would need subsystems responsible for things like fear, anger, pleasure, something like the human limbic system, or whatever else we have in that skull. Otherwise, there's just no way for it to experience any kind of drive towards any action, no way to feel threatened by people or feel the need to ensure its own survival in the case of conflict, no way to even have any interests that might go in conflict with those of humans. And of course, there's still mystery around this whole consciousness thing. Now, if you stayed till here, I can't possibly tell you how excited I am that you decided to spend this bit of time with me. My limbic system is just That was it for now. I will see you next time. Go do something useful.